Good morning, Geo. This is the start of climate. I'm going to have to be speaking from the side here because every time I stand in front of the screen, the color goes all crazy and you won't be able to see any of the notes that I'm trying to explain because I don't have my three competent helpers here. Kudos to you. So here we go. So bear with me here. We're going to try and do this together.
Good to see you.
This is climate. So, just basic stuff here. See, I'll tell you. Look at what happens. Oh, hey, oh, yeah, see it goes crazy. Day versus night. How we get day, how we get night. I believe you understand this already. I would imagine you're perceptive enough to understand that sometimes there's dark and sometimes there's daylight. So the difference between daylight and nighttime is how our world rotates around its axis, okay, and you can see the tilt of the axis is 23.5 just about, and that axis stays consistent all the way around throughout our seasons, and that's one of the biggest reasons why we have longer days and longer nights at different points of the year. The other point, so this would result in, rotation results in day and night. Revolution, this is one of the reasons that gives us seasons, okay? So this would be when we kind of do a big circle around the sun, and it is responsible in seasons, as you can see here. So again, these are your four checkpoints here: March, June, September, and December. I'm going to all deal with them at about the 21st, just so that we can keep consistent with a date. So we've just gone through our spring equinox, where that is 12 hours of daylight and 12 hours of darkness, which I'll explain later. Okay? So rotation gives us day and night. Revolution gives us seasons. But you need something else with revolution. I'm going to skip to what's called cloud cover, so I know it's hard to see this. I'm going to be posting these notes so you can kind of go along with them as you listen to them. And best part about this is you can watch them over and over and over and over and over again until it's beaten into you and you understand it perfectly, right? So, I'm not sure if you've ever noticed, if you've ever been outside at night, specifically if you are perceptive enough to feel the difference in temperatures when there are clouds or when there are not. Clouds I want to consider kind of like a blanket, that if you have clouds, it kind of keeps that radiation in, and therefore there's less difference between daylight temperatures and nighttime temperatures. If there's no clouds, then you're going to notice a very different, this is one of the definitions I asked you to know: temperature range, so the difference between highest and lowest, and in this case we're talking about 24 hours. Okay, so when you have cloud cover, it's going to decrease that range in your temperature range for 24 hours. So, difference in day length, again, in June and in December, you're going to notice very different things around here specifically. We are far in the northern hemisphere, okay? So when you're far away from the equator, you're going to see more difference and more variety in temperatures and in the amount of sun. So June would be our kind of longest month of sun, and December would be kind of our shortest, and that's when our solstices happen, June 21st and December 21st. So, as I said before, another thing that goes with seasons, you can't, if the world's never tilted and continued to go around as one, things would stay the exact same the whole time. Okay, so you have to have a tilt and the revolution for things to change and us to feel any different, specifically the further away you get from the equator. Okay, so you need both to have what we call seasons. Around the equator, their seasons might be different. They might get a dry season and a wet season, but they're both going to be hot. Here in Winnipeg, because we are far away from the equator, you and I both know that things get very different every 6 months, every 3 months, really. Okay? So that would be these 4 dates here. So, bringing us to these names here, solstice and equinox. Solstices happen every 6 months, and so do the equinoxes. Therefore, one of these dates you're going to have every 3 months. Usually, and I'm going to say that they happen, I'll just put all this up here for you. December 21st and June 21st and September 21st and March 21st. Those are 3 months separated from each other. So there is a way to explain this, and in terms of fluctuations of sunlight and darkness, etc., I would think it's pretty obvious for us to say something like, well, it's way darker in the wintertime than in the summertime, and these are the days that happen. We just went through March 21st, okay? And therefore, can I stand here? Nope, that messes everything up, doesn't it? Sorry, guys. You'll just have to deal with my hand puppets. So, December 21st and June 21st, those would be your longest and shortest day. March 21st and September 21st, those would be your kind of half and half days. One way I find easy to kind of remember the dates would be equinox sounds like equal. And on the equinox dates, you have equal amounts of sunlight and darkness. Okay, so that's one way you can kind of think about it. One big thing, that's right, one big thing, is we know when our longest day is in the northern hemisphere. Now, as we're going to get to know shortly, latitude makes a massive difference when talking about climates. Longitude makes no difference, latitude makes all the difference. Okay? So, when we are experiencing our longest day in the north, somewhere in the south is experiencing their shortest day because of our tilt. Okay, and that revolution again. Sometimes you're pointed towards the sun, sometimes you're not. And that will change these dates accordingly.